Thanks, everybody. By the way, did Steve Clark from NanoHub at Home?
He's
here today.
I'm not sure if he's here today, but he's going to speak next week to finish up his talk that got interrupted last time with the internet issues.
Okay. So I'm not really going to talk about what's happened in the past year. I'm going to talk about some ideas for stuff going forward, and some of this has a bit of overlap with the talk that we just heard. So, you know, if we imagine in the future that we've kind of solved the supply side of making BOINC big, and that we have 100 million volunteers, or maybe a bunch of cars or whatever, there's still the demand side, and the fact that currently BOINC benefits a fairly small number of scientists, and we'd like to expand that to thousands, or however many people are doing high throughput computing. So I've talked about this a lot mostly with Kevin Reed, and we imagined there's this conference, supercomputing, that happens every year, that is sort of the focal point of the high performance computing world, and it's attended by a lot of these scientists that are kind of our potential target audience. So if we imagine that we had a booth at supercomputing, and we're handing out flyers to people walking by, there's the question of, what would that flyer say? What would we, how would we ask people to try out BOINC? Ideally, the experience that we want them to have would be a very quick and initially positive experience, where within, let's say, a half hour, they're actually running a bunch of jobs in parallel on computers that they don't own. And we would want a seamless path from that initial experience to a larger scenario where they're using potentially millions of computers. Lawrence talked about HD Condor, and in a certain sense, HD Condor is the competitor for BOINC. It's a system for high throughput computing that uses organizational resources like cluster nodes, and they've used that to build a system called Open Science Grid that really has a very nice test drive experience. And a few weeks ago, I sent around a video that they've made that shows how to get started doing computing on Open Science Grid really easily. So what should the BOINC test drive experience be? Well, here's a list of things that I don't think it should require. One is reading any of our current BOINC documentation. This documentation built up over the years to address the issues of large and complex projects like SETI at Home and Einstein at Home. And really, if you sit down without having seen it before, it's kind of a nightmare, and it looks like you need to understand hundreds of pages of minutia to do anything. I don't think the experience should involve writing XML or doing any sort of sysadmin. It should not involve creating a website or doing anything to recruit volunteers. It should not require that you learn how to build your apps on Windows or Mac or anything like that, or write any code. So I'll propose kind of an organization for this test drive, and it's based on a few components. There's first one of them is what I'll call the app library. This is something that Kevin proposed a few years ago, and the idea is to get a collection of widely used science applications. There's a bunch of them in the molecular dynamics world that most people working in those areas use, and there may be other applications in AI or in climate. The idea is that this BOINC app library would have a bunch of these, and for each application, it would have pre-built executables for as many different platforms and CPU features and GPU types as are relevant to that application, together with plan class specifications for each one of those versions. And the idea is that apps in the library, app versions, should be secure in the sense that running them on a computer, regardless of the input files and command line parameters that you use, should not pose a security risk. So you should be able to run it on somebody's home computer, and even if there's a malicious hacker who submits the job and prepares the input files, they should not be able to cause any damage on that computer. The library would export in XML the list of these app versions and their hashes. And the BOINC client in a future version would import this list in a secure way from the library, and it would be able to look at an app version and know whether it's from the library by looking at the hash. Furthermore, the BOINC client would have a new feature where an attachment to a project could be marked as restricted, which means that project can only run apps that are from the app library. And just as an aside, the task of maintaining this app library would be quite a bit of work. You'd have to track the changes to all these different open source science applications. You'd need to test them against input files, make sure they compute the same outputs, and it would be more than an hour every couple of months. The library could also be useful for purposes other than the one I'm describing here. For example, in the future, we may need to bundle applications with the BOINC Android client, and those could come out of this app library. Okay, the second component of this test drive is what I'll call the demo grid, which is a set of hosts running the BOINC client, maybe a few hundred of them, but it's hosts that are willing to run jobs for anybody in restricted mode, meaning that they will only run applications from the BOINC app library, and therefore they get this guarantee of a certain level of security. These nodes could come from a bunch of different places. Companies could volunteer some of their cluster nodes, or we could use Amazon instances. There may be volunteers who are adventurous and would want to participate. The BOINC clients in this demo grid would be attached to a project, to an account manager, namely ScienceUnited, which would tell them what projects to compute for, and I'll talk about how that would work in a minute. The third component is what I'll call BOINC Central, which is a BOINC project whose function it is to distribute jobs for test drivers, basically, so that they can get work done without setting up a BOINC server and a BOINC project. This project would have all of the apps from the BOINC library and no other apps. ScienceUnited, which is an account manager that I originally developed to provide an interface so that users could sign up for science areas rather than for specific projects. Its function is to sort of be a controller and to dynamically attach hosts to projects. One may as well use this account manager, and the idea is that it would know which hosts are in the demo grid, and it would also know the properties of different projects, in particular the extent to which they're vetted. I'll talk about a bit later what I mean by vetted, and in particular there's kind of two levels of it, and this account manager would know about that stuff and use that to determine what projects to attach hosts to. So those are the components: the library, BOINC Central, the account manager. So now moving on to the test drive experience. What this flyer would say. What we want people to do right away. Well, they would create an account somewhere, and that would be protected in the usual ways with reCAPTCHA. And having done that, they would immediately be able to submit jobs. And I think it would be easy to provide two flavors of this. One is a command line version based more or less on what htCondor provides, where you can make a kind of a submit file that describes a batch of jobs, what application you want to use. It would have to be one of the applications from the BOINC library, and a list of either input files or command lines or both. And then a bunch of commands, analogous to the Condor commands for submitting a batch, finding its status, aborting it if you want, getting the output files. So that's one flavor of the very simple test drive, and like I say, that would let you get started getting access to a significant amount of computing power within the first 10 minutes. A different version of the interface would be web-based, kind of similar to what Ritas was showing, where you pick an app. Again, you specify a bunch of jobs, and there's buttons for doing the different commands. So the implementation of all this is kind of straightforward. These two different ways of submitting jobs would use the existing RPCs that BOINC has for submitting and controlling jobs and for managing files, which are HTTP based, and the jobs would run on the computers of the demo grid. There's some, of course, there's some issues. This would be a framework where anybody could get distributed computing without any real authentication and without paying. There's a couple of ways of kind of throttling this to keep people from abusing it. Kevin pointed out a mechanism where we could host the user's files, the input and output files, on Amazon in a way that requires them to pay the costs of the uploads and downloads. And of course, anything that makes them pay would limit their use of it. It might also be possible to charge them directly in some way. So anyway, this whole thing would be vaguely analogous to the Open Science Grid, with a couple of big differences. One is that there's no vetting or authentication of the job submitters, and the other one is that it would have this this concept, which is key in BOINC, which is that a given application can have a whole bunch of different versions for different platforms and different GPUs. And when you submit a job, you submit it to the application, not to a particular app version. For some scientists, this facility, the ability to run a few dozen jobs kind of sporadically, may be all that they ever need. And furthermore, I think it's reasonable to include the VirtualBox wrapper in the BOINC library, which means that you can potentially run any program that you can put into a Docker image, and it would be nice to use BOINC to Docker and the tools that the people at TAC have developed to make a nice interface for this. And I about a year ago, I wrote a proposal for a system that kind of maintains your Docker images for you, and hides Docker completely from the job submitter. You just have to, give it an executable, and it makes the Docker images for you. There's also some issues related to job sizes. Currently in BOINC, you have to fill in all these numbers for the amount of memory and the amount of disk and the runtime estimates. Those are things we should not require of people, but for various reasons, it may be good for the system to dynamically estimate those and to make predictions for the future jobs that you submit. So this is something that could be developed on top of this. Okay, so that's kind of the simplest and most limited version of the test drive. As people want more capacity, there's a couple of things we can do. So the kind of the second tier of this, it's still unvetted, but now it's going to be distributed so that instead of the jobs going through this central server, they go through your own BOINC server. And the idea here is you create your own BOINC server, but it's kind of a black box to you. You don't have to read the documentation about the BOINC server or Apache config files or any of this other stuff. All you need to do is have a Linux machine that's visible on the internet. In other words, it's not inside a firewall, and install the BOINC server in that machine, which could be done from a yum package or BOINC server Docker or something like that, and then run some command line tools to be developed, which install apps from the BOINC library into your server, and then register this with BOINC Central, which would kind of distribute it to ScienceUnited. So now it would be kind of the same thing. You would submit jobs that would run on the demo grid hosts, but instead of those jobs going through BOINC Central, they would get served off of the server that you've created. And this would avoid a potential bottleneck in terms of server performance and file serving. It would kind of move everything from BOINC Central, which might be slow, to your BOINC server, which would be faster. Okay, so to move from kind of the small scale version of the test drive, where you have a couple of hundred machines, to the larger scale, where you have access to tens of thousands or potentially millions of machines, this is where we need to have vetting. There's really two levels of vetting, which currently are combined into one in BOINC, but we can separate them into two parts. The first part is that you convince us that your identity and your affiliation are correct, and that the kind of computing you're going to do is what you claim. So in other words, if you tell us that you're from a particular university and that you're doing biomedical computing in a, with a certain scientific goal, you have to convince us of that, and if you do, then you're vetted at the partial level. Full vetting adds to that. That you need to convince us that the apps that you run, which now do no longer have to be apps from the BOINC library, but can be your own apps that you supply, are not malware, that they don't have security risks, again, that they do the kind of computing that you claim, and you have to convince us that you're implementing code signing correctly. In other words, that you're keeping your private key on a secure machine and following the protocol for code signing. So if for job submitters, and when I say users here, by the way, I mean job submitters, that's my terminology, is a user is a scientist, not a volunteer. So for partially vetted users, you can use either the central or the distributed model for where your jobs get served from. But now, instead of just running in the demo grid, your jobs will run on all of the hosts that are attached to ScienceUnited, which currently is not a huge number. It's in the range of 5,000, but hopefully in the future will be bigger and will encompass most of the volunteer base. If you're a fully vetted user, which means that we trust you to use your own applications and that they're secure. First of all, you have to use the distributed model. You have to use your own server. We don't want your applications to live on BOINC Central. You're able to add your own apps to that server. I think the current BOINC tools work pretty well for this. And the way that this is implemented is that, well, first of all, your project is listed on the BOINC website, just the way that all projects are now. And if people want to, they can attach directly to it, not go through ScienceUnited. But in addition, your project is registered on ScienceUnited together with its keywords. In other words, its science areas and its location. And it will get computing power from whatever ScienceUnited hosts have signed up to do that work in that particular area, or maybe in that location, depending on the preferences. So I'm just going to skip some of this. Result validation may or may not be an issue. Some applications don't even care about it. I think climate prediction doesn't. They have sort of internal validation by looking at the consistency of the files. One interesting thing that Kevin pointed out is that as part of the BOINC app library, that could include validators for each one of the applications. Of course, validators depend on the format of the output files and the the tolerances for the different values. So if we wanted to include that, the library would be a logical place to do that. So implementing all this, this is a proposal. This is not a plan for we're going to get this done anytime soon. Most of the stuff here is stuff that I can implement pretty easily, and some of the pieces, like the command line interface for job submission, those are things that somebody else could do. They're pretty big tasks. I'd be happy if somebody did that. I think the biggest chunk of work here is actually building the BOINC library and going out and finding the sources for all these applications, compiling them on a bunch of different platforms, doing all this testing. So if anybody wants to help with that, that's probably the place where we could use help the most. So yeah, so kind of wrapping up here, my view is that if we want to get 1,000 scientists using BOINC, we need something like this. We need a better, simpler, shorter, more effective test drive than what we currently have. Yeah. So, and getting back to the question of how we can implement this, one approach. This the whole thing is kind of a neat idea, and it's possible that I could get a grant from NSF to do it, and they would hire that would let me hire some people to work on it. I think that we can do it within the BOINC community, but it's going to require a few people to kind of get behind it and help me out with it. So that's all I have.